Okay, so today I will present Tensorfuzz debugging neural network with coverage-guided fuzzing. So it is published on the Proceeding of the 36th International Conference on Machine Learning, which is also ICML, and it is, so it's by 4 authors from team of Google Brain. So actually, it's Ian Goodfellow's team in Google Brain on GAN. And so the paper was proposed by Ian Goodfellow's team. And for the 4 authors, first 3 of them are like the team member. When the paper is published, the first 3 authors are the team member of Ian Goodfellow. And for the first author, Augustus Odena, so his area is GAN and semi-supervised learning. So actually, the second author, Catherine Olson, is also her area is GAN, and but before she was in Ian's group, she focused on reinforcement learning, and for the third author, actually he is also a prof in CMU, but he is also part of Google Brain, and and he works on distributed systems and networks, and the final author, Ian Goodfellow, he is known as the father of GAN. Yep. So mainly, so that's the authors of this paper, and and it's basically Ian's team's work. Yeah. So the background of this paper is that neural networks are difficult to interpret and debug. So this paper proposed a general way to test neural networks. So before introducing the idea of this paper, we need to know what is coverage-guided fuzzing first. So although the image on the right is a fuzzer process on neural network, but actually the procedure is also same on traditional software. So it mainly have 5 steps to do the fuzzing. So I will introduce it one by one. So this coverage-guided fuzzing is used mainly in software testings in modern softwares. And it is used to test softwares to find bugs in certain softwares. And for the procedure, so at first, it will have a seed corpus to initialize input corpus. So this input corpus can be, so it's the first step will be input corpus initialization. So it will have certain corpus to feed into the train software, sorry, it's not train software, but the test software, and to see which one gives a good result or will crash the software. So there's an input corpus. Then it will have an input chooser to choose several inputs from the input corpus. Then it will apply a mutator to the input that is chosen in previous part. So it is called a mutator. Then the mutated inputs will be fed into software. Although it's neural networks here, but actually it's software. So neural network can be viewed as a special software. So the input after mutation will be pushed into the software to see 2 results. One is the objective function. So this objective function is to view that this input is a success input or not success input. So for a normal software, the objective function will be if this software crashes or not. But for models, it can have other object functions. And also, there will have a coverage analyzer. This coverage analyzer controls if the mutated input can be added into input corpus or not. So this coverage, and so the procedure is like this. If the analyzer finds that the coverage increases, then the mutated input will be put into the input corpus, else it will just pass. So the workflow is just like this. It's quite simple by the graph, right? So Anyone got any questions for the whole procedure of our general fuzzer process?
Yeah, so in traditional testing, so the overall goal is to find more coverage. So for traditional
No,
programs,
it's not find coverage. It's a coverage guided testing. So actually the main goal is not to improve the coverage, but to find the goals by to find the bugs by this coverage guide.
yeah, of course, the ultimate goal is to find something abnormal, right? You just want to write a crash. But the point is that sometimes it's very hard to define what is crash. For example, in a normal programs, if we input an input as 1 and it return output as 2, and how do we now see the outcome is correct or not? Right? It's very hard to say that. So, but anyway, for example, we will have some standard oracle, like if I input 1, if the program crash, then we know something wrong is just here. So, but if you want to explore as many bugs as possible, and coverage is a very important indicators. And full coverage, we're not saying that we have found all the bug. If some other part of the code or some part of the neural branches has not been covered, it means something we haven't tested. And my question here is that can you raise a few examples of objective functions?
Yeah, actually, I will rush it in later parts of the presentation.
Yeah, so because for neural network model, of course, I know they may have some bug like they will derive the not neighbor errors or divided
Yeah, so
by zero errors.
I will
Yeah.
introduce it later. Yeah. So okay, so now we will go to the traditional software testing fuzzing. So for input, the normal input is so in the traditional scenario, the input will be any input accepted by the software, and the input chooser will be just random sampler. And for the mutator, any acceptable modification to the input will be the mutator, and actually this mutator will be problem specialized by the software it is testing. And the coverage analyzer is just the branch coverage, which is introduced by Lin Yun just now. So it will, so there will be many if or switch in software, and if this input will lead to a new if branch or switch branch that is not matched before, then this mutated input will be added to the input corpus. So which is just so the increase criteria is any new branch is reached. And the objective function, as mentioned for software, is usually any bugs happens for the input, like a normal behavior or so, or even the program crashes. Yeah, so that's normal traditional software testing. But in the case of neural network, the settings will be a little bit different. So the key is actually the coverage analyzer, but I will introduce others first. So the input. So since actually neural network will have a more strict input requirement for the input, so the input will be any validated input accepted by the model. So so but actually when the model here are more referring to the CNN models. So the model, so for RNNs, they used any characters that is in a in the input training corpus to be valid input. So so that's the input part. And the input chooser part, they use a random sampler also, but they found that if the priority for new inputs are favored, then it will be more easy to find bugs. So the new input here is that it means that the newly added samples that is added to the corpus. Yeah, and the mutator here, and they introduced how to mutate image in the paper. So it is to add white noise, And second is to element-wise modification. For example, they randomly pick several several points in the image and flip its size, and also means clipping. So just clip a part of the image. And for the objective function, it is task specific. So some of reasonable task object function is that not a number detection. So if in the calculation any not a number is found, then means that the objective is achieved and we found a valid input that will raise errors.
So here I have a problem. So can you go back to previous two slides? Yeah, this ones. So if since Wang Chao, you know about evolutionary algorithm, you know about evolutionary algorithm. So evolutionary algorithms is just so given the existing solutions, we understand we define the objective functions for how to define the score. So then we keep mutating such a solution. Then we observe the mutated score. So we keep such a process, and when the solution and we just keep the mutated solution with higher score. And after iterations, and we just reported or found mutated solutions with best scores. That's the idea of evolution. Just like the, for example, genetic algorithms, the hill climbing algorithms, annual seeding algorithms. So they all fall into that category. And for this further process, it's just using existing, and it can be considered as a specific hill climbing or genetic algorithms. And each input is actually solutions, and the object function or the coverage analyzer. So here is what I quite confused about it. So once we get a corpus and it will fit into network, there's supposed to be a mechanism to saying that what is score for this input corpus. And if this input corpus have a high score, then we keep further mutating on that input corpus with high score, right? So here you have two components. One is objective function and one is a coverage analyzer. And which component, my question is, which component is going to give the score?
So the coverage analyzer is the one gives the score. So
And
a higher score.
Yeah, so the coverage analyzer gives the score, but why is that called objective function?
So objective function. So coverage analyzer.
The function returns 0 or 1, or return a continuous score between 0 or 1.
Oh, okay. So actually, the evolution is a bit different. So for the evolution algorithm, you mentioned that a higher score necessarily means that the input is better, but here a higher score does not mean that it satisfies. So it does not necessarily satisfy the objective function.
It is possible. So usually we will define.
Can you let me finish?
Okay.
So this coverage analyzer, what it does is only to let the input to explore as much dimensions or the place that is exist in the input space. Then, so if it, so it's you can just think like it's exploring on a very, so the input space is very large.
The diversity. Right? You're looking to the diversity.
Yeah. So this coverage analyzer just gives us like a relative score for how good it explores the unseen place. If it is an unseen place, then we add it. So so the coverage analyzer, the goal of coverage analyzer is just to include the much more unseen data that is related to the known data. So instead of randomly exploring the input space, the coverage analyzer will prefer the space that is near to the current known space, but is still unknown. And among the space it has explored, some of them may achieve the objective function, and some of them may not. So that's why these two are different. But in the evolution algorithm, during evolutions, a good score, like we find a point that have a high score, then it also stands for that better score is near this good score. But here in the, so the objective function here is a little bit different with coverage guided fuzzing here.
I understand you think that there's two goals. The first goal is we like to have the diversity. We want to find more diverse input corpus as possible. And the second goal is that we want to find, for example, not a number of exceptions and which input may trigger the not a number of exceptions or whatever, the zero division exceptions, right? But usually it is but despite there's two goals, but the problems do fit into the evolution algorithms. So the first is that we may have a multi-objective evolution algorithm. So that means evolution can consider two evolving goals at the same time. For example, there is a concept of the parietal frontier, etc. There's still some very mature area for that. Even more naive way that we just combine two scopes. The first goal is that the diversity score. That means once it explores a new branch, once it triggers new neurons, it activates new neurons, and we give it a higher score. And then we have another score evaluating how likely it might trigger the not-a-number exceptions. So we're still giving it a score. So for example, suppose there's a neuron, the neuron weights is very, very large. So it will have a potential to trigger not-a-number. In that case, we still give a score. Then we combine these two scores and let the model evolve. So that is still the case.
Yeah, I understand what you mean.
Yeah. I think I have made myself understood. So here for their approach, now let's back to their description. Anyway, this is a paper they wrote. So they have only for this fuzzing process or this evolution process, there's supposed to be only one score, and they only care about the diversity. And once they explore the diversities and they find object functions or which they trigger or when they find another number, they just record it. And there's no score to evaluate how likely an input is going to trigger such an object function or trigger such exception. Is there a score for that?
Can you repeat?
The repeat is that because the name of the component is called an objective function, right? Yeah. So and according to your slides, your two slides later, and you're saying that the function may evaluating whether it's not a number, whether there's another exception. So is there a measurement to evaluate how likely an input is going to trigger such a exception?
No. So it's just no, I don't think they have in this.
Okay, so these object functions just return a true or false.
It's just a binary.
It's a true or false. Okay. So it will. I just think about it will be more efficient if we can define measurement. For example, if it is divided by 0 error, so we can just see we can just measure how far away the denominator and the numerator is. So the bigger it is, more likely it's the zero division exceptions. Or not a number, suppose a super large number or super small or super large negative number. So when we have those scores, the fuzzing process could be more effective.
Okay, so another one is quantized version mismatch detection. So under this scenario, actually I will introduce it later. So you just know that some models will have its quantized version during release, but full version during training. But it is usually very hard to manually find some examples that will give different output for the quantized version versus full versions. But yeah,
sorry, the quantized version, the version for training. Or version for
so you usually during training, so it will use float 32 for every weight. But for the quantized version, it like we want to release a version that should be that is more easily to be run on mobile. Maybe they will use float 8 version or float 16 version. So usually it's very hard to find some samples that will give different results in these two versions. But the author proposed that this will using the mismatch of these two as a function, the coverage objective function, the coverage guide will the coverage guide fuzzing will easily find such samples. Okay, so next
is Aaron there? Is Aaron there? Is Aaron?
Yeah.
Yeah. So this idea is very similar to the EVS-weight framework, right? Overall idea. So, but the problem is that the EVS-weight is working on the traditional programs, and here it's looking to the neurons. It's looking to the how the neuron will have some bugs, but the overall idea is extremely similar. Okay. What please keep
sorry,
going.
I have a question.
Yes.
I still don't understand what is the mismatch detection, quantized version mismatch detection.
So you
Yeah.
still you are still not clear about this quantized version mismatch. So normally, for example, so it's just precise degree. So I'm not sure how to say it. So usually a number is represented as float 32. So which means that we'll use 32 bits to store one float number. But in certain cases, like we want this model to be able to run on mobile phone or smaller devices, we'll just pick the first 16. So we'll use a float 16 number to cut the number to, like, for example, there's a number is called 0111111, and we need 32 bits to store it. But if we only do 16 bits to store, we can only represent number as 01111, for example. So ideally, there must exist some samples that will let the two different versions give different output, right? Because the number is not the exact same. But it's usually hard to find.
Since you go such details, I may have a follow-up questions. So getting this quantized version, is there a version migration? So for example, if we train a float 32 versions on a desktop or on the server, and then we just cut or cast such a float 32 into the float 16, or we just need to retrain a model based on float 16.
Normally, just cutting is fine. So for most samples, there will not be problems. But yeah, so that's I can answer you.
Maybe you have another comment, a small quick comment. So in software, there is a technique called differential testing. The differential testing, this idea once I talked to Chen Chao, but he's gone now. So the idea is that we have model 1 M1, and then we have model 2 M2, right? We know that, and we assume that we know model 1 and model 2 actually should have the same input and output. Given the same input, and model 1 and model 2 is going to have the same output. So the fuzzing approach can define a loss function, an object function, based on the outcome of both M1 and M2. For example, the object could be the function M1 minus function M2, right? And assume that M1 and M2 can provide a continuous solution. For example, this is one, maybe this provides a function 0.9, and this provides a function 0.91, right? And based on the labels, they will also be considered as a true label, whatever it is. But then we keep mutating such input so that this function can be for this function, the value of the absolute value of the object function can be enlarged. And finally, we will find a discrepancy between model and model 2. So this problem, I'm not sure how they done it, but if for a typical or classical solution for that is that we just define two models, and the objective function can be defined on the discrepancy between the model 1 and model 2.
Yeah, that's how they do it. Yeah.
Okay, that's what they do. Okay. Okay, so for their point, it means that object function is not a binary, right? If that case is not binary, so it means that object function can be customized.
But it is a binary. So if it's same, then it's true. Then it's for if the two version is same, then it's true.
No, not necessarily. So for example, the function giving a continuous number. So for example, the function f m1 F1 and F2. F1 gave a score 0.9 and F2 gave a score 0.91. So this is not a binary. It definitely is not a binary object function.
So it's just an evaluation of the how the input satisfies our goal. Yeah, you can just say that.
And my point is that this is a signal for evolution. For example, giving an input I, we find this discrepancy is 0.01, and then we keep another input I2, and the discrepancy is 0.012, right? So an input 2 is mutated from input 1. So it means that the next time we can mutate based on I2 instead of I1. So keep enlarge this discrepancy. So this may not be just a binary function. It could be a continuous function and keep continuously provide the evolution signal. Right.
10. Yeah, I think.
I don't know is this idea included by the Tensorfuzz or but actually this is not a new idea. How is this the novelty is not enough as is not qualified as a new publication.
Okay, so let me continue. So for next, I will go to the most important part that is different from the original traditional one, because so the coverage analyzer. So for original for the normal software, there will be a lot of if or switch branches to see if the input is good or not. So if the input has explored much input space, but for neural network, we cannot use such ones. So how can we do this? It will use approximate nearest neighbor algorithm. So I will introduce it. So before it, I will say the neuron coverage that is used in my FYP project. So if a ReLU is activated, we just say that it is we will use the activation of ReLU as a coverage guide. And there are several variants for this neuron coverage. However, researchers find that it's very easy to achieve 100 coverage, and afterwards input corpus is fixed, and they cannot to explore more. So there's an explanation. There's a test that around 25 samples are enough to make 100 neuron coverage. So that's why this.
How hard is the network? 25 samples can cover 100% of the activation.
So I think so. Anyways, this number is very, very small compared to the input space. So
it is surprised. Okay.
Yeah, so there's a research showing that. So it's very, very easy to achieve this. Yeah. So how can we determine the coverage for a neural network model? So they will treat the activation of all neurons or a subset of them as one vector. Then, if the activation of the new sample vector is at least L Euclidean distance away from all existing activations of input corpus, then the coverage increases and added into the input corpus. So this one is also quite clear. So for example,
so it looks into the combination of coverage instead of the coverage per se, right?
So actually it's exploring the
combination space. So for example, maybe I just read it. So 1, 0, and 0, 1. And this actually, for example, if we have only 2 neurons, and these 2 samples will achieve 100% of coverage. But we're still looking to 0, 0, and 1, 1, right? So it will have the L Euclidean distance for that. Yeah, so that's the way forward. And that's a different thought. But my thought is that because at 100, do you remember we once we have a discussion before on neuron coverage, right? But this is a long time ago.
Yeah.
And we still have quite a puzzle because sometimes the rule looks such a way, and it's very hard to say. Of course, this is triggered, but if the model triggered in this area is still triggered, but these two triggering value actually quite different, and also the negative value is always the same because it's only output 0. But for the positive values, yeah, it's very tricky that. So my straightforward
Actually, I'm not sure they are using 0, 1 activation or use the number to activate. They already just mentioned the activation of the neurons. So I'm not so sure the activation vector they use are the output or the binary one.
I assume they're both binary. You can see 25 samples we can achieve 100% coverage.
No, I mean the early trials. Actually, they are not using the early trial. So that's one is not used.
But they're used based on early trial. So what our discussion is that given a real function x, right? It will output either 0 or some positive value k, right? So, but the k will be different. So the k will be when k it will be quite different when k is equal to 1 and k is to 1,000. They may represent two very different case scenarios in the neuron activation scenario.
Okay, so
my point is that if we would like to increase the space, we can further
they can use
a step function, function to cut the neuron.
Yeah,
okay. I just make the topic a bit.
So and they also tried using a subset of them as one vector. So yeah, so in their experiment they found that using the activation of the layers before the final output layer is enough to achieve a good score.
Diversity to achieve
to achieve a good diversity. Yeah. So no need to use all the neurons, but the activation of the layers before the softmax is enough. Okay, so the following are 3 successful experiments they have done using their method. So also actually for the whole procedure, do you guys get any questions about this whole procedure, like how they choose samples and how they test?
Yeah, so feel free to ask questions.
So yeah, so I have to say that it's a quite straightforward way to test. Yeah. So and so in their paper they include 3 successful usage of this Tensorfuzz, and the first is not a number detection, and the objective function will be any NaN occurs during computation, and this in the experiment part, the author says that this Tensorfuzz found NAS quickly across 10 different random initializations. So yeah, and they compare a baseline with random search, which means random add mutated samples to corpus, but not random generate input samples. And they say that it's 100 times faster using the one that is used. Yeah, so that's experiment one. And for the experiment 2, so I have explained that usually it is kind of hard to find difference between the output of the model and the output of its quantized versions. And the Tensorfuzz found that 17% of test samples can be predicted differently if fuzzed. So for example, if I choose some of the samples as as a input corpus, and then use it to fuzz, and like around 70% of them are able to find a fuzzed version that will cause different predictions. And the object function will be just the output similarity. Like if it's the same, then it's.
So here it is a little bit. So from your point of view, how different is from the adversary sample generation and etc. fuzzing?
So for me, fuzzing is more
a different. As long as we change a different. So because
actually the fuzzing is still. So the gain is more like using a network to generate, but fuzzing is using a more human-defined way of modifying the input.
Yeah, as long as we have a different attack loss function on the adversary sample generations, and we may achieve the same result, right? And also for the fuzzings, and it's still because for adversary sample generations, we need to control the mutation distance. That means a mutated version should not be too far away from the original version.
Yeah.
Otherwise, the mutation, if the model has been changed to completely different images. It is no strange that the label just changed.
So actually, I believe this fuzzing is more like a testing, but not to use to increase the model's capability. So it just to use to find if there are some bugs in the models.
In advanced samples, it can still have arguments. So you just need to find problems where the model is vulnerable to, find samples where the model is vulnerable. And maybe later we can still apply the adversary trainings or data augmentations to fix the model.
Yeah, so actually it also can help in semantic preserving code transformation or just refactoring. So usually you will for example, you have already wrote a model and you want to transform the model without but you found this implementation is not fast enough or quick enough. So you want to refactor it to another version, but you are not sure if the two refactored versions are equal. So you can use this one to run tests and use output similarity to be the objective functions. And so it can easily explore if the refactoring one is the exact same with original one, or if there are some samples are unable to predict the same. Yep. So that's another usage. So it can be used during refactoring. Yeah, that's the second experiment. And the first experiment is quite even. So it's just in the paper, it just says that it successfully found that the implementation of a commonly used DC GAN has issues with certain loss information. And the loss function, the objective function they use is that the loss was high and the gradient was close to 0. So usually if such things happens, it means that the implementation has some problem. And they successfully found that this repo have some implementation bugs, and they use Tensorfuzz to find it. There are several samples have such phenomena, and they, after looking into it, and then he found that this one has some bugs, and they have to fix it. So
does anyone have a question here? So why?
I have a question. So do you mean this model is like pre-trained and then you find some input to make?
Sorry, I can't hear you clearly. So
hello. What about now?
Yeah, it's clear. It's clear.
Yeah. Do you mean that the GAN model was pre-trained and then you try to find some images that can make the loss to be high or the gradient make
yes. So this model is a pre-trained model on the GitHub with like 3K or 30K plus usage and stats, and they find that so there exist some samples that will this objective function achieved, and they using this information they found that there is some small bugs in the loss implementation and such that.
But does that image looks real?
They don't include in its report, so I'm not sure. Yeah.
So maybe I have a question for Wang Chao. I may consider you have to try to answer. So my question is that why is a problem that the loss is high and the gradient is close to 0? Why is a problem?
Because usually a high loss stands for a high.
It's a question. Yeah, it's a question for it. But anyway, so that's the answer is correct. But usually when the loss is high, it means that it will may trigger more of the change or evolutions. But when we find the high gradient is actually go to 0, it means that network structure have some gradient disappearing problem. Or diminution. The gradient became diminution based because of the architecture or something else.
Yeah.
But I still have the concern that since they are using a mutation like clipping, like the random noise, so it's still, especially for clipping, I'm not sure whether after clipping, the image is still under the distribution, it is still conform to the distribution assumption.
So I'm not sure either. Yeah. So what they do is more like to a generic guidance of how to test a network that is going to be released. Yeah. But I think if you are try to fool the network, there's always a way that you can do that. So yeah. So that's why I think this paper's idea is quite straightforward, and the results, yeah, and it can achieve certain results. But
Is there any formula in this paper? Because it's an ICML paper. So which year did it publish?
2019. Yeah, 2019.
So just 2 years ago.
Yeah.
So
So
2 years ago. So we just
there's no
formula.
Actually, there's one formula, but the formula, yeah,
It's very simple.
it's very simple. So I can just show you. So there's only one formula that is show. Yeah, there's one algorithm like how to do the.
It's not a formula. It's just a pseudocode.
Yeah, it's just a pseudocode, and because it has open source library release, so yeah, it can be. It's called Tensorfuzz. Yeah, you can just check if you guys are interested to find the bugs in TensorFlow models. Yeah, because I believe it has open source library release, so they do not include much technical details, but just the result and the overview of how they do it.
Okay.
Yeah, I think that's all for my presentation.
Yeah, that's great. Wang Chao's presentation is always very clear. And this paper, despite it's simple, but it provides fuzzing solutions or the vulnerability or bug detection to the framework for neural network model.
Okay, so I will stop sharing.
Okay, thanks, Wang Chao. Eric, will be the next.
Yeah, okay. Can see, right?
Yeah, please go ahead.
Hello?
Yeah. Yeah, hello? Now we can see, you can see your,
Hello?
Yeah, hello? We can hear you. Hello? Hello, Aaron? Hello, can you hear me? Hello? Hello, Xiang, can you hear me?
Yeah, I can hear you.
So we can.
Sorry, hold on a while. I cannot hear you.
Hello? Hello?
Hello?
Hello? Yeah, we can hear you.
Okay, can.
Hmm.
Sorry about that. Okay, yeah, so this is the paper I'm presenting on faster variational execution with transparent bytecode transformation. So there are 4 authors for this paper. One is Wang, which is a PhD student. The other one is Jens, which is a researcher. Lucas Lazarek, which is a PhD student, and lastly Christian Kessner, which is a associate professor in the uni. So just an overview of the proposed approach in this paper. So computer programs, they often come with a lot of variations, and these variations allow programs to act differently according to a user's needs. So example is just, for example, variations in the command line options, and also you can use configuration files to change the execution of a program. So configuration options are most commonly used, and this is because it provides flexible extension points for adding new features. Yeah, but obviously flexibility comes at the cost of potential feature conflicts, and usually it arises when one feature interferes with another feature in an unintended way. So we need an efficient way of detecting all these conflicts and managing interaction of variations. So there are some challenges posed by interactions of variations. So the number of all possible configurations is exponential. For example, you have 50 different settings. There are a total of 2 to about 50 combinations, and so exhaustive testing of all configurations is not very realistic. Interactions are often impossible to foresee. So sometimes plugins are developed by different individual developers, so they might not take note of other plugin interactions. And also the effects of variations, they often propagate globally in programs. So usually these variables are global variables, so it's hard to detect interaction of them because because they are global, and you can't really do that with data flow analysis easily. So what researchers proposed before this is through a dynamic analysis technique. So they analyze the effects of multiple variations during runtime. And this work is usually called variational execution. And the proposed work in this paper is built on this idea. So we'll talk a bit about variational execution first. So the key idea is that we execute a program with concrete values, but these concrete values usually is a combination of multiple alternative values. So the alternative values are represent the different values for different configurations. So they do this by making each variable hold a conditional value, and basically this conditional value, it just consists of all possible values for that variable. So we'll go through a small example later, and then using conditional values, we perform a computation conditionally in a variability context. So this one is more related for when there are branches, what happen. And variability context is similar to like a path condition in symbolic execution, where an operation will only modify values in the path of the configuration space indicated by this variability context.
What's the definition of variability context?
They didn't really define it. Yeah, this is what they gave.
Okay, so
but later, yeah, there's an example. Yeah. So by doing so, we variational execution only has to execute the program once to test all possible configurations. So this is the example code that I'll be going through. So on the left is a extract from some of the WordPress source code, and the main method is this to HTML method. And then, so firstly we identify that there is three configurations at the top. So smiley, weather, and Fahrenheit. So these three configurations can give rise to a total of 2 to the power 3 combinations based on whether either are true or false. Okay, so variational execution does this by initializing these three variables with a conditional value on the right. So we represent these three variables as alpha, beta, and gamma, and we indicate that both of them have two possible values, which is true or false. Okay, so if we run through the code, right now at the start, the variability context is true for now, because we haven't run into any branches yet. So for line 6 and line 7, it is true, and we can just execute the code normally. So so this is why this is good, is because now that we know that it's always true, so we only had to execute line 6 and line 7 once, instead of if we do a brute force execution for all 8 configurations, we have to execute line 6 and line 7 8 times, even though they do not affect, they do not change between all 8 different configurations. So this is why one of the inefficiencies of variational execution. And then now the interesting part is in line 8, which is line 8 over here. So now we only execute the block if smiley is true. So we have this variability context when smiley, which is alpha, is true, and then only if it's true, then we execute that line, c equals c dot replace whatever. So right now, because all values are variability conditions, so c is also a variability condition where it contains 2 different values depending on what alpha is. So if alpha is true, then we execute this replacement, which is why we get this first possible value. And if alpha is false, then we get this second value where we don't execute this line 9 and we don't replace c. So now you can see that this variable c has, in one execution we take note of all possible values for it, which is just these 2 values here. So for the next branch, basically we are doing the same thing, and we find that we can have 3 possible values for c over here. And then finally, at line 14, because the variability context is still true, because we already exit all the if conditions and all the possible branches. We already went through all of them. So now they are merged, and we can execute line 14 just once to get string f, and then finally we can return all possible values.
It is an interesting example, but one question is that since some of the variable like c, it can have multiple variable values, right? Given the configuration. And I assume that it is possible that such a variable will be there. So first, I want to say that even it is a true value, it have multiple true values. The c, is it possible that c will have multiple true values? For example, it actually will have a combination explosion. There are a lot we have to consider the effect of loop, right?
Yeah.
If it is a loop, so how do we expand the loop? So maybe we'll question one question one by one. So given such a value, let's see here, focusing on in line 12, right? So line 12. So if we go smellies, or so if FC, so if line 12 will still have some condition, right? It will still consider some. Okay, so it is an alpha. So alpha goes true, it will be value 1, and if beta be true, alpha be true, will be another value.
Alpha is true.
Alpha true. If alpha is both true, or the smiley is true, it will become 1 value, right? And but what if the smiley and weather are both to be true? And how does it represent the value of C?
And whether is true. Yeah, so if both are true, then this will be another variability condition. So it will be like a bracket. But in this case, because both their values will equate to the same value, which is this. Because if whether is true, then we want to replace this text.
Yeah, another question is that it seems that this result cannot be achieved by executing once, right? We still need to require multiple times. For example, suppose let me raise such an example. Let smiley be true and whether be true, and smiley be false and whether be true, right? In this case, the value achieved by 1, 1 will be different between value 2, 0, 1. It means that we still have, suppose we have 2 options there, we still need to run 4 times to get a result.
I mean, in the end, we are going through just like one pass of the code because we are keeping track of all possible values.
Yeah, I know. Finally, according to their summarizations, they will have they're showing just in one result, showing the value of the C, with the assumption that there is no. But my question is that how to construct such a trace? And this trace actually is a combination of 4 traces, right? So that means if we want to construct such a trace to show you that C can have different values, we have to execute the program 4 times. And assuming that we have 100 variables, so that means that we have to execute the program for 2 to 100 times.
As in the
And also you can see there's a get weather. So in this case, if we want to have such a trace, it means that we need to execute 8 times. Need to execute the program 8 times, and then combine it all together.
As in the execution, the multiple execution is only like when you're trying to evaluate the variable, correct? Because like for example, if C, so at the start C has 2 possible values here, right? And then now
it is 2 possible value indeed, but sometimes this value is achieved in a dynamic way, right? Achieved dynamic way to do the bytecode instrumentations and got the values. But the point is that the final value, suppose they have 8 combinations, and as a return value H plus C plus F, it is supposed to have 8 values, right? And given that they have possible 8 values, you want to show all the possible values. It is still the approach may still suffer from the combination explosion problem. The combination explosion problem.
yes, but
and giving your presented motivation saying that if we're testing the feature interaction, it will still the combination explosion is a big problem. But if they get such a variational traces, it will still. And how do they address the combination explosion problem?
Yeah, so I mean in the end you have to find all the possible combinations to see if there's a bug.
If we want to see all the combination problems, shouldn't we execute all the combination, all the option combination?
Yeah, so as in the thing is we still keep track of all possible combinations, correct? So like at the start we keep track of each variable, like what possible configurations there are, which is really just true and false. And then we just go through one pass and see how both these true and false will affect each variable.
Okay.
So we don't really have to run the whole program 8 times. We run it once, but then
Once.
okay, of course some instructions, for example, c dot replace. Now when you do c dot replace, you have to keep track of two.
Yeah. So pointing that, for
Two different-
example, here at line 8. At line 8, we will know that the similarity can be either true or false, right?
Yeah.
So in this case, you previously saying that line 6 and line 7 can be executed for only once. But here we have two ways to execute it. So, but if they want to do such a variational trace, do they have to modify the JVM to restore all the program contents when executing line 6 and line 7?
So as in, like line 6 and line 7 is executed once, then it branches for.
Yeah, what I'm asking is technically, from a technical point of view, what I ask is that from a technical point of view, how do they only execute line 6 and line 7 for only once?
Yeah, so as in they run it once, and then because when they run it once, they already have like.
Yeah, they already have value of H and C. I understand this part. But the point that how can they only execute once? Because for branch, let's say this is branch 8 and this branch 9, right? 6, 7, 8, 9. And if they want to achieve the value of 9, so have to re-execute the program and get the value of line 6 and line 7.
No, so they
store the context.
Yeah.
They store so if they want to store the context, it means that they have to modify the JVM to this end.
Yes. So there are a few ways to do that, but one example is like they have to manually rewrite all this code here. And we'll go through an example of that later.
Okay.
So what the proposed approach in this paper is how to automatically do the manual rewriting.
And what rewriting?
So in order to like store the different contexts and stuff, they have to manually rewrite this source code. Like that is one of the
manually rewrite it or automating refactoring the code.
No, so the usual way now is to manually rewrite this source code. So this paper approach is to don't manually write it to make it an automatic process.
Okay, let's see your example.
Yeah. So yeah, the main idea of variable execution is that we keep track of all possible values for each variable, so that we can just pass through the code once.
Okay.
So you can see by doing so.
But still not once, right? Okay, still once you think because you can store the context.
Yeah.
And it's actually, but the running time is still very large. Right?
Yeah.
So the idea is that going to save the common trace. So if there's a common trace among all executions, you do not need to execute those common trace repetitively. They just save this once, and they just then based on their approach, they will just extend the variational trace.
Yeah, it's how they transform the bytecode, this approach. Yeah. So for variational execution, in the end we'll get all the possible values, and then if you inspect, for example, the value of C right now, you can see that there is a problematic interaction between Smiley and weather. So one of the possible results of C is the one highlighted in red, and that is not really a proper HTML element. So this can be spotted as a bug manually. Yeah, and yeah, so basically after a single run of variational execution, we can have all the info of all the info of how all the options interact, and then yeah, we manually debug it. Yeah, so usually variational execution is done through a manual rewrite of the source code. And a bit more about the implementation, the usual common implementation of VE. So usually they manually modify the source code, or they can also modify the language interpreter. And obviously this is often tedious and error prone. And however, there has been previous results that show that VE is still useful, but the main error is still the scalability issues, and also some of the research only work on a small academic examples.
Yeah, this is a very common problem actually. So from an idea level, it's just okay, but from the implementations, still involve a lot of tricky part, especially for how do we manipulate the code. And if I'm the one who implemented it, I somehow need to send some signals to ask the JVM to restore the context so that I can re-execute from a certain point, program point.
Yeah. So from the previous example code, this is how manually rewriting the code will look like. Okay, to achieve this variability execution. So I won't go through in detail a lot, but I'll go through some of the main points. So at the start, we know that each configuration, they have 2 possible values. So now we have to translate all variables into this V wrapper, and this V wrapper basically has all the possible values for this variable. So even for local variables used, they are also they're also casted into this V object wrapper. Okay, and then you can see that for all the if branches, which is this line, okay, they are transformed into something like this, where you have to create the context for this branch, and then the branch will just change to whether this context is satisfiable.
Let me see. So what is a CTX? CTX is
so CTX is the context for this method. So
can you show me the original code? So maybe it would be much better to align the original code and their modified code.
Yeah, because it's a bit small, so I didn't really put them together.
Okay, there's no parameter for that.
Maybe I will.
Okay.
Yeah, so all the methods will have an additional parameter, which is the context.
And what does this context contain?
Yeah, this part I'm not really very sure, but it's basically the context of like what is true and what is false. So whenever we have a branch, apart from just knowing that the smarty has to be true, you have to make sure that the context presently is true as well. Yeah, because
what if it is false? What if the context is false? It's true.
Yeah, so if it's false, then there is something wrong with the code, and then the true block won't be executed already.
What if there's a loop?
Sorry?
What if there's a loop?
A loop?
Yeah.
I'm not very sure. didn't really go through the example for that.
Let me think about it. So when we have the simple context, we only record a simple context. So the simple context, yeah, I'm not that very familiar with the when true. What does the when true function means? When true means it is and context. Yeah, so my question is here. So the value of C here, right? They will contains two contexts. And how this piece of code can allow this C contains the context when smiley and with true or false? Right, by this way, so if they want to execute it for only once, the idea is that the C should contains the value under both the scenario when the smiley is true or false, right? True and false. So C should contain all this stuff. So from my point of view, there's just no way. So if I'm the one implementing this idea, I will just store the context. Actually, the context is not just a source code level, because I think source code level cannot address these problems. So when they executing, would you please let me go through the original code?
Yep.
So if I'm the one who do this, I will restore. I will keep all the context in JVM executions instead of space. So if we execute the smileys, we just if there are if conditions, and we just executing this. If it's true, we're executing these functions, and then when it's executing these ones, we will go back to restore the program state again, and then we execute the case when smiley is false. So it means that all the, for example, the heap information, stat information will just recover at this program point and re-execute again. So that is way to do this. But from my point of view, it's very hard to rewrite a source code to do the trick, because if once they're removed, the scenario becomes more complicated. For example, if I say this is while smiley, and then we include different functions, and how can this be handled? The way that we have a lot of the configuration becomes much more complicated. And if there is a function that if certain condition is satisfied, we will let the smiley to be false, and then the program will jump out of the loop, and then the program becomes far more complicated. And from my point of view, it's very hard to see source code rewriting can help on this matter. Okay, please go on.
Yeah, so yeah, also not very clear on a lot of details of how they rewrite it. Yeah, but I think the main idea is still that they keep track of all possible values for each variable. Yeah, so we can see that is transforming the code is non-trivial, and also it almost doubles the size of the original code. And it, of course, the intention of the original program make it hard for developers to understand and debug it. So these issues can be resolved if we use an automatic transformation that is transparent to developers. So this is the proposed approach to automatically transform programs during their intermediate representation. So in this case, it's the bytecode, so that it can mirror the effects of a manual rewrite. And then this resulting bytecode can then be executed on an unmodified JVM. So you have to ensure that they encode the conditional control flow correctly, such that both branches of a control flow condition can be executed in different configurations. But then after they are executed, they have to be merged again. So they also perform some additional optimizations, such as finding instructions that do not need to be transformed, as they do not affect any variations in the program. So for the bytecode transformation, the idea is they want to transform each bytecode instruction into from the original program to a sequence of another bytecode instructions. So usually, ideally, they want the transformation to be independent. So each instruction should not be affected by other instructions around it. But generally, this is not really possible because an instruction often affects another instruction because they can leave data on the operand stack. So briefly, the operand stack is used internally in JVM to help exchange data between instructions. So for example, some instructions they load values and some instructions they take the values. And
this part we're fairly familiar with that, right? So Aaron, you yourself went to manipulate the operand stack yourself. Yeah.
So one way to help them is by creating this transformation invariants. So firstly, they have to. So the first invariant is that all local variables and object fields, they store conditional values. Second invariant is that all values on the stack are conditional values. And lastly, all methods, they take conditional values as parameters and also return conditional values. So they have to ensure that these invariants hold before and after the execution of each transformed bytecode sequence.
Let me check about the assess the local transformation of individual all local variables. What do these conditions indicate? This condition variable is that the variable used as for the use in some instruction like if equal if instruction, right? So
which one?
So condition values means the variables or the means the variables used in the if instruction.
No, the conditional values is basically the possible values for that variable.
Possible values.
Like for example, just now the string C has multiple possible values, right?
So what do you mean? Because you can see in this sentence, all local variable fields store conditional value. Storing, you mean this is about so this is a noun. What this is an expression or this is a sentence?
As in this is the assertion that they want to make when after they transform the bytecode, they have to make sure that this assertion is true.
All the I didn't see it. So
I think basically they are saying that like all the values used, you have to change them into conditional values because they want to store all possible values for that variable.
okay, maybe we can see it later. So this invariant I didn't see. Can you give a few examples on why this variable is bold? and the transformation will be safe.
Yeah, I don't think they give much examples, but we'll go through some of the bytecode instructions.
Okay.
Yeah, so to achieve the invariance, they change all parameters and local variables in the method frame to this v type to store conditional values. So, for example, for load and store instructions, these instructions basically transfer values between the local variables and the stack, and they basically just say that they transform them, like even in the primitive ones, to transform them into the A load instruction, which is basically loading an object type instruction. And then for the store instructions, they need more attention because they can be executed under different variability contexts. So only some values should be overwritten. So for example, if we have we store 1 into x under the context of true, but we store 2 to x under the context of A, then x will have the conditional value of A, 2, 1, which means that x has the value of 2 under the context of A, else it has the value of 1. Yep, so this is how the conditional values work. Yeah. Then for arithmetic and type conversion instructions, these instructions usually they just compute a result based on 1 or 2 values on the stack and then push the result value back on the stack. So for example, I add, it takes 2 integer values on the stack, adds them together, and then push the results back onto the stack. So based on invariant 2, where basically all the values on the stack has to be conditional values. So they invoke this SMAP function using the current variability context on the stack's conditional values, and then they perform the original operation on each possible value. So basically now, because each value in the stack is a conditional value, so they have to make sure they perform the operation on each of these values. And then there are some operand stack management instructions. So these instructions directly manipulate the values on the stack. So for example, there's pop or sort instructions. And then they basically it works the same for conditional and concrete values. So don't need to transform them. Then for method invocation and return instructions. So method invocations, they pass the top stack values as arguments to the method, and they push the method's result back to the stack. Yeah, so since the method arguments and return types are now conditional values, they can just be passed along directly. So another thing is for object types. So class instances, basically we have to transform all the
small question. Suppose there's a branch, right? Suppose there's if conditions, and when, for example, suppose you write something like this. If there's a variable b, and we were executing this part of code, right? And for this part of code, when executing this code, the stack still require all the variables on the stack, the frame stack is conditional variables, because it is only requires b, right? Only when b is true, the code will be executed.
Mm-hmm.
and before that there can be very different contexts.
Mm.
And suppose there's else. So somehow it means that giving an execution, it didn't need to execute it if block and else block simultaneously.
Oh yeah, so yeah, we'll go through the branch conditions later. But basically, if there's a if else, basically they change all, they'll change the else statement to a if statement also. So it's possible to for one execution to run through both.
If it is run through both, the state will be different, right? So suppose I'm saying that if v I plus plus, and then I equals I plus 10, right? So if I change if into else, then how do we know that this I is I preserved here? Suppose I equals 2, right?
Mm-hmm.
There are two different branches. And the effect of if we change else into if, how do we know that the results after execution this block will not be used, and we're still using the state before the branch? Right. This I, if we change else into if, this I we use supposed to be 2 instead of 3, right? And after we executing this sentence or statement, the value of I will be 3. And from the beginning is 2. And if we change else to if, and we start here, we'll begin with 13. And by right it's supposed to be 12. And how do they address this problem?
As in from my understanding, so for example, each variable I you have is a conditional value, right? So in this case, this condition is v, is it? So based on this condition, whether v is true or false, if it's true, then I will be 3. If not, then I will be 12. So in this case, we know that at the end of this if else branch, I will have 2 possible values.
So basically they were actually extended the variable. So just record. So more likely you maintain an individual variables for each branch. Right?
Yeah. So
maybe how about we make things more complicated? Here the while, and here it's here the and the W, and we call that else, we call that, right? In this case, whether we execute whether we try out. And by the way, so here we only look into the binary value. All the variables are, or all the options here are binary option.
mm-hmm.
Let me think about it. Yeah, I just feel annoyed. Do you think their program transformation is safe?
I mean, from the experiments they run, it seems to work.
Safe.
Yeah, but
it means that for example, suppose the C, this C is supposed to be a very, very huge map, right? And each time they execute it, they will. Okay, so it's point that they will. So that means for all the, for example, there's a lot of, suppose there's a lot of context, and each variable, because each affected variable will keep all, suppose that we have, suppose there have 100 contexts. That means all the variables in the program, in the source code, in the source code programs, they will maintain 100 of its version. All right. Suppose for now C is not an individual variable. C is actually a map now, right? C is actually a map now. And suppose before C, they have 100 contexts, and each context indicating the C will have different value, right? So in this case, it means that this C, it will have to maintain a different, for example, each context will corresponding to individual C, C1, C2, to Cn. And but of course, this context will indicate what the context it is. For example, the smiley equals true and whether equals false, etc.
Yeah, so as in you only contain the values that like in the end, C will only contain values, C will only contain like unique different values. So like for example, just now the example that there are 4 different configurations for the smiley and weather, right? But at the end, C only keep track of 3 values because for all the 4 combinations that's
C, I think C will actually maintains 8 values. C will have 8 values. Right. So each value corresponding a context, because the C, finally it returns what H plus F plus G, right? So this return value will actually have 8 versions according to their design. Right. Okay. And for their context, I'm not done. So for this context, getting such a if they change if else into okay, so it just they just need to rewrite into the if conditions. Okay, please go on. But somehow I somehow convinced of with the approach. But definitely they were involved a lot of overhead, maybe a memory or the memory exception there, because they introduced anyway, so they're used the number the size of memory will at least use 100. Suppose there are a lot of states, they will maintain 100 times more memory in their solution. Right.
Yeah. So for class instances, basically the fields will change to a conditional value type. So for example, if 2 instances of a same class, they differ in one field, then we represent the difference in the conditional value for that field. So we do this instead of a conditional reference to 2 copies of the object. So we do this so that we can share.
Yeah, I just feel it involves a lot of work, especially for object reference. Suppose we have, for example, if A equals B, right? And there are actually 2 object reference. But it's just okay that we keep version. Whenever we keep a version of B, and we just will out that given the context, we will know which B we use here. And that's okay. Yeah. They can do this by save some memory.
Yeah. And for arrays, they transform an array into an array of conditional values. But they also support variation of arrays to support arrays of different length. So for example,
definitely,
a object array is represented as such. So this one is about the how they resolve the branch issue. So in the branching statement, we may need to execute both branches under different contexts. But then after we execute both statements, we have to join both the branches back together so that we can share data for subsequent executions.
Let me see. The branch statement is in both branches. What? How do they merge them? Just curious. How do they merge them?
Yeah. So basically they group instructions into this thing called a V block. So a V block is a group of instructions that are statically guaranteed to always share the same context at runtime. And these V blocks are separated by conditional jumps. So these jumps depend on conditional values. And so it means that the execution will be split. And then after executing multiple V blocks, you can join the executions. So
I just still feel like the worry, still worry me a little bit. So give me the context, right? So what if the context will write some global variables? Oh, but the global variables do have multiple versions. So I just am very curious about, that means that because the program could be very complicated. So it means that to be safe, we should make almost all the programs have multiple versions, right? And what if we're using an array list? Array list is a data structure or data structure in GDK, right? And then the data array list will be here. Suppose one version, we say that the list dot add a 1, and another branch, okay, we say that list remove 1, right? And how do they do the bytecode transformation?
As in the list will be an array, right?
Inside the implementation of array list to support array, but you need to modify. It means that you need to completely change all the dependent library, right? Because all the variables dependent on the state variable need to be changed.
Yeah, but
and also all the method call need to be changed in API. For example, suppose we have a mass function, and we're going to calculate the max, right? And the max was supposed to have two int a and b, whatever. So, but now what are we feeding to such a method call? So all interface need to be changed. Right? It's supposed to be very, very complicated in terms of source code. And they will introduce maybe 10 times, and this is just a rough estimation, 10 times the bytecode if we want to handle everything. Let alone there's a naive invocation. Because the max or some other mathematical functions, or say finally they will be invoked some DLL file, naive. They're using some naive function. How do they handle this one? So this solution is supposed to be, it sounds interesting, but if you want to be very systematic, like, yeah, I'm still a little bit worried about the details. Okay, let's keep going on.
Yep. So how they construct the V blocks, basically they merge basic blocks in a CFG iteratively until a fixed point is reached. So a block B1 can be merged with a block B2 to form a V block if the jump between B1 and B2 is not conditional. So then by creating V blocks, they can order it based on a strict transitive predecessor relation based on the CFG. So this relation is true if, for example, there's a path from block I to block J, but not from block J to block I. Then they execute the V blocks based on this order. And the proof of correctness is shown in the paper. So this is the example of the get whether method. How it's manually rewritten. So actually, this branch checking whether the Fahrenheit is true is actually just one if statement. So let me show the previous one. Yeah, so the get whether method is over here, and it's basically a if else statement now to check whether it's whether if Fahrenheit is true. So it is rewritten into two separate if statements, so that both the if and else block can be executed. So for the V blocks, basically we have four V blocks. So one is before the if statements, one is for the true block of the if statement, one is for the else block of the if statement, and lastly, after we merge it, we have one statement which is return the result. So at the start, before we execute any of the blocks, we keep track of the variability context of each of the block. So in short, is the VC. So the context of block 0 at the start, it is just the context, the context that is passed to the method, and the rest will be by default false. And then once we right before we execute the block 1, okay, we can see it from the condition of this if branch. We have to make sure that Fahrenheit is true and the current context is true. This is why the context of B1 is as such. And then for block 2, we know that is the else block, so it is when it is not Fahrenheit. And then the context of B3 will remain as false. So we execute block 1, and then after executing block, after we execute block 1, we can change the context of block 3, because now we know that block 3 can be executed right after block 1, and so the context of block 3 will be the same as the context of block 1. And then based on the execution order, we execute block 2. And now after executing block 2, we know that block 3 can also be executed after block 2. So we can combine the context of block 1 and block 2 to get eventually the context of the original context, which is CTX. So now,
but in this case, CTX will have two additional versions. For example, return. This return value actually will at least have two versions of return, right? Two versions of return variable. Right. And then the merge. So merge here is that they consider all the cases together. Okay, got it.
Yeah. So now that we merge the context, so now block 3 can be just executed in a single context and only in like one pass. So we can share the data for more efficiency.
So basically, each time we have a branch, it just have another version. Almost all the variables will have another version. Right? All the affected variable will have another version. So the state space will be very, very huge. And I don't know, and also I don't know how they could handle how they interact with this, or how they rewrite based on the, for example, another return variable is not mean, right? So all the It means all interface or the method. What do you deal with method call? So interface just need to change it altogether, right? And if they call some basic array-based hash map, and how they handle that, they have a version of hash map, multiple version of hash map.
Yeah, but the thing is they're modifying the bytecode, right? So they don't really have to change the source code.
Yeah, I understand they rewrite the bytecode. And I'm just still curious about what is max. They're using max, and this return variable will be changed because this interface cannot be changed, right? But it means that once they are calling some JDK class, the interface of calling JDK class needs to be totally right. And for example, the hash map key set. Suppose the hash map key set is to quite a lot. And by the way, have they published their source code?
Yeah, if I'm not wrong, is on Git.
It's on GitHub.
Yeah.
Okay. Let's keep going.
Yeah. So that's about it for the approach. So now is the experiment setup. So they call this approach VarexC, which is built on top of VarexJ, a state-of-the-art VE engine for Java.
Execution engine for Java. So it's still a version of JDK.
Sorry?
Execution engine. So they modify JVM, right? So this is the execution engine for Java. So VarexC or VarexJ are another version of JDK or Java virtual machine.
I'm not very sure about this, but
right, they're saying that they will not modify JVM. They're just creating new Java bytecode, right? We write Java bytecode, and if that's the case, why we need a variational execution engine? Or maybe they can just call their intermediate level execution engine.
Yeah, as in they don't modify the JVM.
Okay, let's keep continuing.
Yeah. And then the benchmark programs are the same used in VarexJ. And basically they just compare their approach with VarexJ against these three criteria: the execution time, the memory usage, and the sharing efficiency of vblocks. So this is one of the main result table for the execution time. So yeah, may I go through first? So you see this is the line of codes, and this is the number of possible options, and the total number of possible configurations based on the number of options. Then this JVM, basically they execute the original source code with a single configuration on an unmodified JVM. So basically, for one of these configurations, it takes on average 949 milliseconds to execute the whole program. And then max JVM is basically the maximum time it took for one of the configurations to execute. So for VarexJ and VarexC, basically they executing the same original source code, but of course they transform the bytecode, and then they transform the bytecode to evaluate all possible configurations. That's why the difference in time is VarexJ and VarexC.
I got it. So the table, I got it. So anyway, so they think the performance is better. So do they mention the distinguish, what is the major factor to make the VarexC have a significant improvement over VarixJ?
So the main one is, for example, for the top 3 subjects, basically because they use a lot of like object types, and then because VarixC it shares the data between different instances of objects. So this is their claim, why they say it's faster. And also of course,
they have improvement on objects, right? Also okay. Okay, so VarixJ still modify the interpreter, the language interpreter. Let's see, modify. So because VarixC does not modify the interpreter, but anyway, so yeah, my straightforward idea is that we back up all the program execution state. That may take some time. Okay, keep going on.
Yeah. So the next point is about the memory usage. So yeah, basically VarixC is more memory efficient than VarixJ. So you can see it over here. So it's about it can be up to like 5 times less memory than VarixJ.
But they show the additional memory compared to the original execution.
Yeah, so the original one is the first column.
Okay.
Yeah, so definitely.
So it's only okay. So it's just okay, right? Improvement is less than 10 times.
Yeah.
Okay.
And so finally, I didn't really go through how they analyze this, but we see they had some formula to get the sharing efficiency lah. And yeah, I didn't really have time to understand what all this really meant. But
okay.
The sharing efficiency of the V blocks is mostly optimal. Yeah. So that's about it for the experiment. So to conclude, they propose an approach that is an efficient implementation of variational execution by transforming programs at the bytecode level, transforming individual instructions and modifying control flow of the methods. And they showed that VarixC is 2 to 46 times faster and also saving up to 3/4 of memory usage than the state of the art. Yeah, that's it for the presentation.
Okay, thanks, Aaron. That's a very excellent presentation, and everything will be very clear. Everything is very clear. But from your point, yeah, I didn't have a question for now, but I think my point, at least for us, how to manipulate this, the instrumentations. If their data is really it's very factual and there's no trick to manipulating the experiment data, and their solutions will be very impressive. Right. So I think one of the way to using the approach might be suppose. So I'm not sure whether you have heard about it. It's called what if debugging. What if debugging. So this is one of the idea we learned from one of my mentors. So what if debugging is, but he is not that technical, but the idea is quite simple. So you're saying that what if I modify these programs and how the program execution will look like. For now, they are saying zero problem only address what if this variable changes from true to false or from 1 to 2, right? So I think their idea is what we can borrow here. So what if we modify a few code here, then the program will have very different executing traits. So if we always have approaches that once we have a modifications and we will have 2 executions. one of our solutions that we just align every step on the trace so that we can know what's really going on. But if we can executing 2 versions or multiple versions altogether, I think there's no need to further align the trace, right? Because the trace alignment algorithm is still very time consuming. So if we can somehow have such approach and do fully bytecode transformations, so essentially that's the essential idea that we keep 2 versions of variables from where the code chain started. So that would be they are supposed to be very efficient framework. And then maybe we can think about later. But anyway, you're graduated. Let's think whether there's the follow-up students can finish the tutorial. Anyway, these are very good papers. I'm very glad that you can print the paper well.
Okay, thank you.
Okay, okay, let's go today. Thanks, Aaron. Bye.
Bye.